Back in 2005, a small European probe made history. After a 7-year journey aboard NASA's Cassini spacecraft, the Huygens lander plunged into the thick, orange atmosphere of Titan, Saturn's largest moon. It was the first and, so far, the only time we've ever landed a probe in the outer solar system. Huygens sent back incredible data, but one particular photograph, taken just 5 miles above the surface, continues to puzzle scientists 2 decades later. The image shows a stunning network of branching channels, looking eerily like riverbeds on Earth. But how is that possible? Titan is freezing cold, with an average temperature of minus 179 degrees Celsius. Water there is as hard as rock. The leading theory is that these channels weren't carved by water, but by liquid methane. On Titan, methane acts just like water on Earth. It rains from the sky, flows in rivers, and pools in vast lakes. When Huygens landed, it touched down on a surface that looked like a dried-up delta, littered with icy pebbles. Its instruments confirmed the ground was made of water ice, and the atmosphere was mostly nitrogen with a dash of methane. This chemical cocktail is surprisingly similar to what scientists believe early Earth's atmosphere was like, billions of years ago. It's a primordial world, frozen in time. The thick orange haze that shrouds Titan is made of complex organic molecules called tholins, which are formed when sunlight hits the methane. These tholins are considered potential building blocks for life, making Titan a giant natural laboratory for studying how life might begin. The probe survived for only 72 minutes on the surface, transmitting data before its batteries died. In that short time, it revealed a world that was both alien and strangely familiar. The ground had the consistency of damp sand, and the winds near the surface were surprisingly calm. But the mystery of those river channels in the photograph remained. Were they formed by recent methane rainfall, or are they ancient relics from a time when Titan was more geologically active? We still don't have a definitive answer. Later, the Cassini orbiter used radar to map Titan's surface, discovering enormous lakes of liquid methane near the poles, some larger than North America's Great Lakes. But Huygens landed near the equator, where no large bodies of liquid were seen. This just deepened the mystery. Did the equatorial regions once experience massive floods? Or do they get rare, intense methane downpours? To solve these puzzles, NASA is sending a new mission called Dragonfly. Launching in 2028, Dragonfly isn't a stationary lander. It's a nuclear-powered, car-sized drone that will fly from place to place across Titan's surface. Its goal is to explore dozens of different locations over several years, analyzing the surface chemistry and looking for complex organic molecules. Dragonfly will land in a region of vast dunes near the equator called Shangri-La, where it will have access to some of Titan's oldest and most interesting terrain. This mission will transform our understanding of Titan from a brief 90-minute snapshot into a long-term planetary-scale study. Dragonfly will investigate the chemical pathways that could lead to life, not just on Titan, but potentially elsewhere in the universe. It's a bold next step in our quest to understand our place in the cosmos, building on the legacy of a small probe that gave us our first incredible glimpse of this mysterious world. Thanks for watching, and be sure to subscribe for more deep dives into space exploration.